Hello guys, we're going to take a look at the PowerPoint presentation for lesson 1-2, which is about the order of operations. You should know the basic order of operations. You might not know everything about it, and you might not know that we're going to change the first letter. The first letter you think is a P, please excuse my dear Aunt Sally. We're going to change that P to a G. So we'll see what that means in a minute. Let's take a look. In the past, we talked about algebraic expressions verbally. That's what we just did in the last lesson. And we converted back and forth between verbal and algebraic expressions. And now we are going to evaluate some numerical expressions by using the order of operations, all numbers in these first sets of expressions, numerical. Then we're going to evaluate some algebraic expressions, still using the order of operations. But algebraic means you're going to have some variables, but those variables are going to be replaced with numbers using the substitution when you're given a value for the variable. So we'll see what that means. Basically, once you substitute, it just becomes numerical again. So there's a couple of new vocabulary words, evaluate and order of operations. Evaluate means what you guys would call solve, but it's not really solve because what you solve is an equation. You're not really solving these. What you're doing is you are evaluating them, or you're simplifying them. Sometimes these directions will say simplify, sometimes they'll say evaluate. Basically, to you, it means get an answer. You call it solve, but it's not really solving because it's not an equation. These are expressions. And the order of operations, we'll talk about in a second. You know that there has to be a very standard order of operations because if not, and you had a list of a sequence of operations that you could pick your own order to do them in, every person who did it could get a different answer. So there has to be a standardized way to do it to make sure that everybody follows the same set of rules. So evaluate means get an answer for this, 2 to the 6th power. So you know with an exponent, it means to repeat the multiplication. 2 times itself, that's the base number, 6 times. So you could expand it out to write 6 times multiplying. 6 is the number of times you multiply 2, the factor. And eventually multiply and you'll get an answer of 64. So when you evaluate that, it means get an answer and your final answer is 64. 4 to the 4th power. Remember, it's not 4 times 4, it's 4 times itself 4 times. 4 times 4 is 16. 16 times 4, that's the third 4, that's 64. And then that times the 4th 4 gives you 256. Okay? That's a basic thing. That's just an exponent rule. Now we'll talk about the actual order of operations. I wrote over here sloppily with my mouse, I'm sorry. You used to call it PEMDAS. Please excuse my dear Aunt Sally. We're going to change the P to a G because it's not about just parentheses. There are lots of different grouping symbols you'll use. We'll talk about those in a second. So you're going to evaluate anything that's inside grouping symbols first. And inside the grouping symbols, you could have other operations like an exponent or some multiplication, division, some addition, subtraction. So you're going to follow the order of the rest of these 2, 3, and 4 in that set of grouping symbols if it applies. And then once you get an evaluated simplified number inside the grouping symbols, then you'll move out and you'll evaluate the powers that are outside. Then you'll multiply and divide. Remember, when you multiply and divide, you do not necessarily multiply first. You multiply and divide in the order they're given from left to right. So sometimes you'll divide first and not multiply first. Same for add and subtract. You add and subtract from left to right. So you're not necessarily going to add first. You might be subtracting first. Or you might add, then subtract, then add. For example, if it said like 24 divided by 4 times 2. Well, you would do 24 divided by 4 first and then times 2. 24 divided by 4 is 6. 6 times 2 is 12. As opposed to the opposite, if it said 24 divided by 4 times 2, and you multiplied first, and you multiplied 4 times 2 first, you'd get 8. And then if you divided second, 24 divided by 8 would give you 3. Obviously, 2 different answers. So they said, okay, when you're multiplying and dividing, you're moving from left to right, no matter which one comes first. And then you're going to complete addition and subtraction the same way, from left to right, whichever one comes first. So what is a grouping symbol? Here's a list of different grouping symbols. There's only one here that doesn't apply to the operations. But a grouping symbol, the most basic one you know is parentheses. You've dealt with parentheses plenty of times. Parentheses groups numbers together. Well, if you have parentheses and then you need more parentheses around those parentheses in the same problem, then it gets confusing. So then if you have parentheses already and you need more grouping around that, they use these brackets. Brackets are basically parentheses just around parentheses. Braces are not an operational grouping symbol. Braces are a symbol that groups numbers together as a set. We'll talk about that later. So you won't see braces in this lesson, but it's part of the grouping symbols list that I found. Absolute value bars. They don't have a name. I one time asked a college professor, what are the absolute value bars called? And he said, absolute value bars. And I said, oh, great, thanks. Absolute value, you should know, is the distance away from zero. It takes all numbers and makes them positive because distance is always a positive number. The only time it's not positive is if you find the absolute value of zero, and the answer would be zero because zero is not positive or negative. It's a neutral number. So absolute value bars, if you have an operation inside of absolute value bars, you have to complete that operation inside before you take the absolute value of that set of numbers inside. Same thing for this radical sign. A radical sign is a root, such as a square root or a cube root or a fourth root. You probably haven't seen too many of those, but you've probably seen plenty of square roots, like the square root of 25, you should know is 5. A radical sign could have operations inside of it. So it could say the square root of 20 plus 5 inside. So you'd have to add 20 plus 5 first to get 25, and then do the square root of that, and that would give you 5. And the other common grouping symbol that you don't even think about, but hopefully you know, is a fraction line or a fraction bar. A fraction line or fraction bar can break a set of operations up where you're actually not going to do the order that you would think. Because you would think you'd have to do multiply and divide before add and subtract. But if this fraction line or fraction bar says like 10 plus 6 on top and then 2 on the bottom, the first thing you would actually do is you would do 10 plus 6. So you're going to add before you do the divide by the fraction bar, because the fraction bar creates basic parentheses or groups in the numerator and denominator. See how they have the parentheses inside, kind of surrounding the words fraction and line. So we'll see one of those in a few minutes. Let's start easy. 48 divided by 2 cubed times 3 plus 5. By the way, it might be a good idea to write down some of these things in like a notebook, take some notes for this section, the different types of grouping symbols, and write down these examples, follow them step by step. As I go along, you might have to pause the video, write down the examples as if you were taking notes in class. That's basically what this is. So that being said, 48 divided by 2 cubed, third power is cubed, times 3 plus 5. There's no grouping symbols, no parentheses, no brackets, no fraction bars, no radical symbols, no absolute value. So the grouping symbol step is going to be ignored here. I'm going right to exponents. So the first thing I'll do is I'll do 2 to the third power. And 2 to the third power is 8. Most common thing people do wrong is 2 to the third power and they say 6 because they do 2 times 3. 2 times 2 is 4, and then 4 times another 2 is 8. So they simplified 2 to the third power and got 8. Now you have 48 divided by 8 times 3 plus 5. Here's one of those situations where you have division and multiplication, but you're going to work from left to right. So you're going to divide 48 divided by 8 before you multiply 8 times 3 because of the left to right rule. So divide that, and you get 6. And now multiply 6 times 3 and 18. And the final step is to add 18 plus 5. The last step is going to be addition and or subtraction. In this case, it's addition. And your final answer is 23. Okay? Now I've got some parentheses or other grouping symbols in these next few examples. 8 minus 3 is in parentheses, times 3, another set of parentheses, the quantity of 3 plus 2. So we're going to simplify what's inside the parentheses first. We're going to do this subtraction in this parentheses and this addition in this parentheses. We'll get 5 in both of them. So now I have 5 times 3 parentheses 5. Well, remember, a number next to parentheses, that's another way to write multiplication. So this is all multiplication. It's 5 times 3 times 5. So you can do this in either order now because of the commutative property of multiplication and the associative property of multiplication. I'll multiply it the order it's in. 5 times 3 in the front. 5 times 3 is 15. And then 15 times 5 will give me 75. Notice that this 3 parentheses 5 is not a grouping symbol, quote unquote, parentheses operation. It's just a multiplication. So you could have rewritten this in this middle step as 5 times 3, another multiplication dot times 5. You could have lost a parentheses and just made a dot there. Doing the parentheses step means you simplify something inside. It doesn't mean to multiply what's outside by what's inside that parentheses. Okay? A couple more. Here we have some brackets because we have parentheses here, 6 minus 2, and then more grouping symbols, the brackets around them, including the 12 and the division symbol, and I have a power outside of that. So I'm going to start inside the grouping symbol, and you always, if you have multiple grouping symbols inside of each other, you always work from the inside, the most enclosed one, and then work your way out. So before I do any division here, I'm going to do 6 minus 2 in this inside parentheses. 6 minus 2 is 4. And now I have 12 divided by 4 inside the brackets. I'm still inside of a grouping symbol. 12 divided by 4 is 3. Notice the red is changing every time. And now I have 4 times, remember it's a multiplication, 3 to the power of 2. I have to do the power of 2 first because an exponent comes before multiplication. And the only thing that gets the power of 2 or the square is the 3 inside the grouping symbol. So 3 to the second power, or 3 squared, is 9. And then 4 times 9, my final answer is 36. Okay? And the last little example, here's that grouping symbol fraction bar or fraction line that doesn't actually show anything grouped up here, but this whole numerator is grouped together, and you have to simplify all of that first. This whole denominator is grouped together. You're going to simplify all of that, and then when you get a final total from the top and a final total from the denominator, you're going to divide them because the fraction, of course, tells you to divide. So starting in the numerator, I have an exponent, I have a subtraction, I have a multiplication. Exponent comes first. So 2 to the 5th power, 2 times 2, 5 times, is 32. Now I have a subtraction and a multiplication. Well, I'm going to multiply first. So 32 minus 6 times 2 is 12. And now I'll subtract it. 32 minus 12 is 20. Numerator simplified. Now we'll do the denominator. Oh, sorry about that. I'm going to do the exponent on this 3 first. The power of 3, 3 to the 3rd power is 27. Here's my 27. Now I have a subtraction, a multiplication, a subtraction. I'm going to multiply the 5 times 3 before I do any subtractions. 5 times 3 is 15. 27 minus 15 is 12. And then 12 minus 2 is 10. So I have 20 in my numerator, 10 in my denominator. My final step is to divide because it's a fraction. And 20 divided by 10, final answer 2. There's a lot of steps, I know. I personally would have done the numerator and the denominator individually at the same time. So way back here on this page, I would have been doing this 32 to the 5th power, and I would have done the 3 to the 3rd power 27 at the same time down here. It would have cut my number of steps of writing in half. As long as you're confident in your order of operations, you can do that. That's fine. Work with the numerator and the denominator at the same time separately, and then in the end, get that 20 and 10 to divide. Okay? Take a second, read that one, pause the video, work it out, see what you get. Hopefully you paused it, hopefully you created an answer, you evaluated that expression, and hopefully you got 88. Do the same here. Get ready to pause the video, read this problem, see if you can evaluate and get the answer from the order of operations. Go ahead and pause. And I'm back. I didn't really pause. Hopefully when you worked it out, you got the answer of 3. And the third one, read it down, read it, write it down, pause the video, work it out. And coming back, after you pause and worked it out, I hope that you got the answer of 1. All that work to get 1, really? Ugh. Notice though, they have a couple of answers that are fractions. They didn't make those fractions decimals. Fractions are your friends. Fractions are okay. It's okay to get a fraction answer. Keep that in mind all year and forever in math classes, at least through high school and college and wherever you go. All right, now we'll look at some algebraic expressions. So now we have variables mixed in with our numbers. I have 2, but then everything else is variables, x, y, and z. But notice over here they give me numbers for x. X is 4. So I'm just going to replace that x, substitute a 4 in. Y is 3. I replace that y with a 3. And z is 2. I replace that z with a 2. So your first step is replacing or substitution. So replace the x, y, and z with the numbers that correspond to them. Put them in carefully. It won't always come x, then y, then z in the problem. It won't always be the order they're given in the list of the values. So make sure you're putting the right numbers in the right place. If it said z, then x, then y, and you put the 4 first, you put the 4 in the z place when 4 is the x. Just replace and substitute your numbers in carefully. Well, now I've got the problems like before. Once you substitute in, it looks the same as before. I have exponents inside and then a subtraction. I have exponents outside, I'll do that. And I'll do some multiplication and then I'll do some final addition. So I'm going to go through this, just click for you. You can pause and read if you need to, but I feel like this is repetitive and it's basically the same as the last few problems once you substitute. All right. Multiply. And your final step is to add, and your final answer is 30. And one more of those. Same thing. This was again, it goes x, then y, then z. So you're okay because x comes first, and y, then z. Just be careful when you substitute these numbers in, that you put them in the right places if the variables are out of order. Go ahead and pause, evaluate it out. And if you pause and you're back, hopefully you got the final answer evaluating of 28. Again, sometimes the directions will say evaluate, and sometimes they'll say simplify. Simplify means the same thing. Simplify means if there are operations that can be done and computations that can be done, do it until you can't. Sometimes you can't get down to a final number if there are variables still left over in the problem, if you have an algebraic expression without values for variables. And last but not least, we'll put these together. Oh no, word problems. Each side of the Great Pyramid of Giza, Egypt, is a triangle. The base of each triangle once measured 230 meters. The height of each triangle once measured 187 meters. They say once because if you don't know about the Great Pyramids, they're eroding, they're starting to shrink. The area of the triangle is 1/2 the product of the base and its height. There's your verbal expression or your verbal representation that you're going to have to change into algebraic. The area of a triangle is 1/2 the product of the base and the height. Product means multiply. So let's convert that into an equation. 1/2, and they use B for base and H for height. I told you I love to use variables that match the words so I know what's what. 1/2 times B times H. You should recognize that formula as the formula to find the area of a triangle. It's not a mystery. And now you're going to take the values that you're given the problem, and you're going to substitute in the value that they gave you for the base and the value they gave you for the height. They gave you 230 for the measurement of the base and 187 for the measurement of the height of the triangle. So put them in there. At this point, hopefully, I forgot to tell you this, hopefully all those other problems you did without a calculator. Please don't use a calculator. Use mental math and computation by hand if you have to. This one, not so much. You have 230 times 187 times 1/2. Grab a calculator for this. I wouldn't do this by hand. I would multiply 230 times 187 to get 43,010. That's not necessary. And half of that, just divide it by 2. And your final answer is 21,505 meters squared. Okay? What if the base was 123 and the height 62? We're still going to use that 1/2 times base times height formula. So go ahead and pause the video, work this out, calculate a little bit, see what you get. And hopefully now you're back and you paused and you calculated and you got 3,813 square feet or feet squared. There's our lesson for today. We've reached the end. I have work for you to do now, so let's get to work.